Let's go ahead and start with our warm up here. So we got first times first, that'll be x times x is x squared. The outer terms are x times 5, which will be plus 5x. The inner terms, the two in the middle, 1 times x is x, so plus 1x. And then 1 times 5, last times last, 1 times 5 would be plus 5. And we've seen this from last week using FOIL. And today, instead of canceling out the two middle terms, we should add them together. 5 plus 1 would be 6x. So that'll be x squared plus 6x plus 5. This is stuff that we saw last week when we learned about FOIL. The second problem is the same idea. So first times first, m times m, that's m squared. Outer, m times 6 plus 6m. Inner, negative 4 times m would be minus 4m. And then last, negative 4 times 6 is negative 24. The two terms in the middle, positive 6m, negative 4m, those combine together. 6 minus 4 is 2. So we end up with m squared plus 2m minus 24. So we're going from two binomials using FOIL, ending up with a single trinomial at the end. The last one here on our warm-up, k times k, first times first, k squared. Outer, k times negative 3, minus 3k. Inner, negative 7 times k, minus 7k. And then last, negative 7 times negative 3 is positive 21. Add the two numbers in the middle together, negative 3 and negative 7, that's negative 10. And so we get k squared minus 10k plus 21. And so today what we're going to be doing is essentially starting with problems that look like this, and we're going to be working backwards to get answers that look like these, kind of like we've done the last few days. And it says trinomials like these can be factored back into a product of binomials. Exactly what we did yesterday, similar to what we did on Tuesday. So I want to mention real quick the form that we're looking at. And it says to factor a trinomial of the form x squared plus bx plus c. What that means is the first term in your trinomial is just a squared variable. There's no coefficient. There's no number in front of this first term, right? It's just x squared or m squared or k squared. There's no 2 or 4 or any number in front of this first term. So x squared means no number in front of that first term in your trinomial. It's just a variable squared. And then plus bx is going to be plus or minus some number times x. So b in this case on this first warm up would be 6. On the second one, b is 2. On the third one, b is negative 10. And then the x is just the variable. So x, m, k, that's the variable. And then c is the regular number at the end of the problem. So 5, negative 24, 21. So those are the trinomials of the form x squared plus bx plus c. And what we're trying to do today, in order to break this apart back into a binomial times a binomial, we are trying to find two integers. Let's review integers real quick. What's an integer? Does anybody remember? Yeah. It is a number. Specifically, what type of numbers are integers? Correct. Okay, so just a regular number, not a decimal number. All right, yep, those are both true. There's a little bit more. So integers are, everything you said was correct. So positive or negative whole numbers. That's it. So not decimals, not fractions, whole number values could be positive or could be negative. So that's what integers are. So what we're looking for here are two integers, two numbers, positive or negative whole numbers, that add to equal b. So add to b, whatever the value of b is, those two numbers have to add up to equal the value of b. And those same two integers also have to multiply to equal c. So add to b, multiply to c. That's the big thing about today right there. Finding two numbers that multiply to them or add to the middle value and multiply to the final value. That's what we're trying to figure out today. So if you have a good handle on your times tables, today's lesson, not too bad. If you don't, you can always use a calculator. It'll take you a little bit more time to punch in on your calculator to find out what works. But either way, we'll be able to get to some answers here. And I'm going to give you this first example here. Will kind of explain everything you need to know. And so it says, our guided example says x squared plus 7x plus 12. The first term does not have a number in front of it. It's just a variable squared. plus 7x, so b equals 7, plus 12, c equals 12. So what we're trying to figure out here are two integers that add up to equal the middle number, 7, and the same two numbers that also multiply to equal 12. And it's always best, I think, to start with the multiplication. So look at the last number first, that's a positive 12. What two numbers can you multiply to equal 12 that also add to equal 7? 3 and 4, exactly. So the numbers that we need here are 3 and 4. Now there are other factors of 12. You could have 1 and 12, but 1 plus 12 doesn't equal 7. You could have 6 and 2. 6 plus 2, though, doesn't equal 7. The only two numbers that multiply to a positive 12 and add to a positive 7 are 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. And so what we're going to do is we're going to write two binomials. The first term in each set of parentheses is going to be x. It's going to be that first term there, but just x by itself. And then the other two numbers will be a positive 3 and a positive 4. So the answer here is going to be x plus 3 times x plus 4. So that's how that factors out. And just for this first example, we're going to FOIL this back out. We're going to multiply this back out just to prove that it gets us back to the original trinomial of x squared plus 7x plus 12. So first times first here, x times x is x squared. The outer terms, x times 4 would be plus 4x. The inner terms, 3 times x would be plus 3x. And then the last two terms, 3 times 4 is plus 12. And then you add the two middle terms together. 4x plus 3x is 7x. And so we get x squared plus 7x plus 12, which is exactly what we had at the beginning. And we factor it out and FOIL it back, and we end up with the same thing. So double checking it just to make sure on this first example, and just to show you that this process does work. So that's really it. Finding two numbers that multiply to the last number and the same two numbers that add to the middle number. That's all we're trying to figure out today. So on number 1, I'm going to scoot this down just a little bit. I'll leave the example up there. Both number 1, the value of b is 9, the value of c is 20. So we need two numbers that add to equal 9 and the same two numbers that multiply to equal 20. What do you think? 4 and 5, exactly. 4 times 5 is 20. 4 plus 5 is 9. So I'm just going to write those factors over there, 4 and 5. Those are the two numbers that we need. And so our answer with our parentheses will be not x, but n plus 4 times n plus 5. Now, in your mind, if you had thought 5 and 4, that's fine too. You could have n plus 5 and n plus 4. It doesn't matter which parenthesis those numbers go in. You could have the 5 first and then the 4. It doesn't make a difference. Let's try number 2. Two numbers that, again, it's always best to think of the multiplication first because there are going to be fewer options for the multiplication than the addition. So two numbers that multiply to 18 and the same two numbers that add to 9. 6 and 3, there you go. So 6 and 3 are the two numbers we need. 6 times 3 is 18. 6 plus 3 is 9. So we're going to get w plus 6 times w plus 3, and that's our answer. As soon as you have those two integers, you can write your answer. Problem number 3. Let's take a look at that one. We need two numbers that multiply to 24 and the same two numbers that add to equal 10. Two numbers that multiply to equal 24 and the same two that equal 10. 4 and 6, exactly. And if you're racking your brain and you're having a hard time coming up with it, just start writing out factors of those numbers. You could start with 1 and 24. 1 plus 24 equals 25, so it doesn't work. 2 and 12. 2 plus 12 is 14, so that doesn't work. 3 and 8. 3 plus 8 is 11, so that doesn't work, but we're getting closer. 4 and 6, those are the two that actually work. So if you don't know off the top of your head, just make a list of factors and then add them together, see if it works, because visually sometimes it helps to see in front of you on the paper those factor pairs, and then you can add them up and find out if it works or not. But 4 and 6 are the numbers we need here, so we're going to get a plus 4 times a plus 6, and that's our answer. How about number 4? What's that? No, 4 is actually not prime, but what's the only way to multiply two numbers to equal 1? 1 times 1, yeah. So that's it, 1 and 1. Because 1 times 1 is 1 and 1 plus 1 is 2. So that's it for number 4. So we're going to get y plus 1 times y plus 1. However, there is a more condensed way to write this answer. Because it's the same binomial multiplied by itself, we can write it a little bit more condensed as y plus 1 and then a squared on the outside. So if you end up seeing the same thing, the same binomial multiplied by itself like we have here, you can just write the binomial once and then a squared on the outside. So that is set 1. What did you notice as soon as Hayden gets back? Yeah. What did you notice about the types of numbers we had in set 1? What was familiar? What was the same about all of them? Yeah. Yes. Yep. Yes. And then even more specifically, the two numbers that we have for every single one are what kind of numbers? Were there any negatives here? No. Okay, these were all positive. So set 1, I just want you to write both positive. Both positive. Because things are going to change a little bit as we go through the different sets of numbers that we have. And so we're starting off by having both values being positive. But if we look at set 2, we'll move on down to set 2 for a moment. What do you notice about set 2 that's different about set 1? Yeah, and where are the negatives? They're all in the same place. Where are they? They're all the last number, yeah. So the middle number, b, is all positive on this one, but the third value, c, is all negative on this one. What is the only way to multiply two numbers and the result end up being negative? What's the only way for that to happen? And one's a positive, yeah. So positive and negative on this one. So one positive, one negative, and think about this. If you have a positive number and a negative number and you add them together and the result is positive every time on this one, because when you add together, that's the b value, that's the middle value. These are all positive. What does that tell you about those two numbers? If you have a positive and a negative and the result when you add them is positive, what does that tell you? Yeah, the positive number is the bigger number, right? If the negative number was the bigger number, the result would be negative, which we will see. So the positive number is greater. The greater of the two values has to be the positive one. I'm putting air quotes around greater, just because positive is always greater than negative, but we're specifically talking about like absolute value, right? The positive number is further away from 0. And so when you add two numbers together, one positive and one negative, and the further away from 0 one is the positive one, the result of the addition has to be positive. So let's think about number 5 real quick. We need two numbers that multiply to equal negative 18. Just think of two numbers that multiply to equal 18. Start with that. And they're going to add to positive 3 with one of them positive and one of them negative. What's that, 9 and 2? All right. So 9 and 2, if we make one of those two negative, can we end up with a positive 3 as our answer when we add them together? No. Okay. So the larger one has to be the positive one here. So 9 would be positive, 2 would be negative. 9 plus negative 2 is 7. So not quite. So 9 and 2, no, those aren't going to be the ones. What else multiplies equal 18? 6 and 3. All right. So 6 and 3. If the larger one, 6 is the positive and 3 is the negative, if we add those together, does that equal positive 3? 6 plus negative 3 is 3. So these are the numbers we want. Positive 6, negative 3. So n plus 6 times n minus 3, and that's our answer. Now, it does matter on this one which one has the plus and which one has the minus. That is absolutely crucial here. But you could have the minus 3 in the first set and the plus 6 in the second, and that wouldn't make a difference. As long as the negative was with the 3 and the plus is with the 6, you're good to go. All right. How about number 6? Two numbers that multiply to 8, one's positive, one's negative, and they add to equal positive 2. Start just by giving me two numbers that equal 8 when you multiply. 4 and 2. All right. If we make one of those negative, if we make the smaller one negative, does that add to equal 2? Yeah. So 4 and negative 2. X plus 4, x minus 2. Number 7. G squared plus g, which means 1g, minus 6. So we need two numbers that multiply to negative 6 and add to positive 1. And again, if you're struggling through just kind of trying to think about it, put something on paper. What two numbers multiply to equal 6? 3 and 2. If you make one of these negative, if the 2 is negative, does that equal positive 1 when you add them? Yeah. All right, so 3 and negative 2. G plus 3, g minus 2. By the way, this type of problem right here on number 7, this is one of the most commonly missed ones because a lot of people end up putting 6 and 1. I'm not sure exactly why, but if one of those two numbers is positive and one of them is negative with 6 and 1, so if the 6 was negative or the 1 was negative, 6 plus negative 1 is negative 5. And so that can't work there. Just be careful that you really think through it before you put an answer down. How about number 8? Negative 45 for multiplication, positive 4 for addition. And again, just start with two numbers that multiply to equal 45. I can really only think of like two different factor pairs that multiply to equal 45 off the top of my head. 3 if you count 1 and 45, but that's probably not going to be it. What do you think? 5 and 9. All right, so 5 and 9. Which one's negative? Negative 5. Good. So negative 5, positive 9. Negative 5 times 9 is negative 45. Negative 5 plus 9 is 4. So C minus 5 times C plus 9. Awesome. Any questions so far? So here's something that you might find a little bit weird. I actually really enjoy these types of problems because to me, it feels like a puzzle and I really enjoy puzzles. And so it's like trying to find the correct combination. And then once you have that right combination, it's like, cool, I got it. I can plug it in there. I enjoy puzzle games, so it almost feels like a game to me, which probably is a good thing that I teach math because I know math doesn't feel like a game for a lot of people. So if you can kind of make it a game in your mind, it makes it a little bit more, I hesitate to use the word fun, but math can be fun. All right. That was set 2. Let's look at set 3. What do we notice about these ones? These ones are a little bit different still. What's different about this next set? They're all negative, yeah. B and C are both negative. Once again, though, C is negative, which tells us what about the two types of numbers? The only way to multiply to a negative is what? Two negatives would be a positive multiplied together. Yeah. There you go. So again, we're looking for a positive and a negative number, just like set 2. However, so one positive, one negative. That part is the same as set 2, but the big difference is the middle number is negative. So when we add them together, the result is negative. What does that tell us about the two numbers? I'll give you a hint. We wrote this down for set 2. One positive, one negative. The positive is greater. So this one, the negative is greater. Yeah. So the negative number is greater. So when you add two numbers together, one's positive and one is negative, and the result is negative, that means that the negative value is the, quote, greater value. It's the furthest away from 0. So on number 9, We need two numbers that multiply to equal -3, or 3, which means there's only two numbers that work when you multiply to equal 3. What are they? 1 and 3. One of those two has to be negative, and the negative one is the greater one this time. So -3, +1. If we add those together, we get -2. That's exactly what we're going for. So a plus 1 times a minus 3. And that's our answer for number 9. For number 10, there's going to be more factors with 30, but we have to add to equal a -7. One of them is positive, one of them is negative. They multiply to equal -30. What do we think? And if you don't know, just give me two numbers that multiply to equal 30. We can start with that. 10 and 3. All right. Does that work? Which one's negative? 10, yeah. So the greater one is negative. So -10, +3 multiplies to equal -30. -10 plus 3 is -7. All right. So x minus 10 times x plus 3. There we go. Next one, number 11. Just start by thinking of two numbers that multiply to equal 63. There's very few options here. What do we think? Two numbers that multiply to equal 63. It's on the times table. It's one of the lesser used ones, I think, but still there. What do we think? Those are factors of 63, so we can try that. 21 and 3. The greater one has to be the negative. So -21 plus 3 would be -18. So that doesn't get us to -2. So we tried one pair. That one didn't work. What else? 9 and 7. How about that? The greater one would be negative. -9 plus 7, -2. All right, that's it. So b minus 9 and b plus 7. Excellent. Number 12. Two numbers that multiply to equal 64. Eight and 8. All right. So 8 and 8, neither one of these is greater, but if we make one of them negative, they add to equal 0, which would actually be canceling out. So that would be like yesterday's assignment. So 8 and 8 aren't going to work for us. 64. What else multiplies to equal 64? And if you're not sure, just start systematically trying to divide 64 by numbers. Start with 2 and then try 3 and try 4 and 5 and so forth, and see if you can get two whole numbers that would end up working with adding up to -12. If you can create your own like system for figuring it out, you'll be able to get there pretty quickly. All right, let's try that. 16 and 4. -16, because the greater one would be negative. -16 plus 4 equals -12. That's it. So k minus 16 times k plus 4. Kind of like a scavenger hunt. And that's it for set 3. So we've had 3 different types. Set 4, take a look here. What's different about this one? Yeah, so the end is a plus and the middle is a negative. So we're multiplying to equal a positive and we're adding to equal to a negative. What does that tell us about the factors? What's the only way to multiply two numbers to a positive but have those same two numbers add to a negative? Both negative. That's it. These are both negative, which basically means we're doing these like we did set 1. So you're just looking for two numbers that multiply to the one on the end And once you have the two numbers that work with the number on the end and add to the number in the middle, just make them both negative. So you can think of this as a positive 11 to begin with, but as long as you make both numbers negative, you're good to go. So two numbers that multiply to equal 24 and add to 11. And again, if you can't think of them, just start listing numbers that multiply to equal 24. 6 and 4, all right. And they're both going to be negative. Negative 6 and negative 4 would add to equal negative 10. So we're almost there, but not quite. So 6 and 4, nearly. What other two numbers multiply to equal 24? 12 and 2, 8 and 3. 12 and 2 both negative would be negative 14. 8 and 3 both negative, though, would be negative 11. All right. So negative 8 and negative 3. So x minus 8 and x minus 3. Excellent. How about 14? Multiply to 49, add to 14. 7 and 7, yeah. 7 and 7, both negative, multiplies to equal positive 49 and adds to equal negative 14. So x minus 7 times x minus 7. This one is a lot like problem number 4, where we've got the same thing multiplied by itself. So we can actually make that a little bit more compact, and that's x minus 7 and then squared. So if it's the same thing multiplied by itself, you can just do the binomial once with a squared on the outside. A couple more from this set. The next one, this one might take a little bit longer because 72 has a lot of factors. So give me two numbers that multiply to equal 72. (36) and 2. All right, if we add those together, if they're both negative and we add them together, that would be negative 38. So not quite with negative 17. How about another one? 24 and 3. If they're both negative, would be negative 27 instead of negative 17. All right, let's keep going. Which would be negative 22 if you add those together. So we're getting closer. 9 and 8. And if they're both negative, negative 17. Excellent. So negative 9, negative 8. So that'd be x, or sorry, not x, y this time. Y minus 9 times y minus 8. Awesome. All right, last one from this set is m squared minus 15m plus 50. So two numbers that multiply to equal 50 and the same two numbers that add to equal 15. And then just make them both negative. (5 and 10). There you go. So 5 times 10, both negative, is positive 50. Negative 5 plus negative 10 is negative 15. So we're looking at m minus 5 times m minus 10. Cool. So the next 6 problems are mixed practice. And so we are going to, it's basically going to be any problem that we've seen from any of the 4 sets over the next 6 problems here. So number 17. We need to add to a positive 6 and multiply to a negative 16. The only way to multiply to a negative is going to be a positive and a negative. So the plus for B and the minus for C, that was set 2. So we need a positive and a negative, and the positive is greater. And again, just start off with two numbers that multiply to equal 16. Start off simply. Pick two numbers that multiply to equal 16. 8 and 2. All right. 8 and 2. If the bigger of these two is the positive and the smaller one is the negative, does that add to equal positive 6? 8 and negative 2? If we add those together, does it equal 6? Yeah. So that's our answer. A plus 8 times a minus 2. All right, number 18. X squared minus 14x minus 72. So this would be set 3. So again, we need a positive and a negative. This time the negative is the greater value. But again, just start by finding what two numbers multiply to equal 72. We had a few of them already. We had 36 and 2, we had 24 and 3, we had 9 and 8. So if we think about those real quick, if the larger one is negative, negative 36 plus 2 would be negative 34, which doesn't work. Negative 24 plus 3 would be negative 21, which doesn't work. The larger one's negative. Negative 9 plus 8 would be negative 1, which doesn't work. So it's none of these three that we checked earlier. So what other factors are there of 72? Other than 36 and 2, 24 and 3, 9 and 8. What's that? 6 times 12 is also 72. So if we go with 12 and we go with 6, and the 12 is negative, that would be negative 6. So 12 and 6 also doesn't work. 72's got a lot of factors. What else? We checked 4 different factors of 72, and none of them work so far. What did you get, Monica? 18 and 4, yeah. 18 and 4, if the 18 is negative, add those together, you get negative 14. Negative 18 times 4 is negative 72. So we're looking at x minus 18 and x plus 4. Awesome. Okay, number 19. Both of them are positive, so both numbers are going to be positive as well. So two factors that multiply to equal 40, and the same two factors that add to equal 13. So it can't be 10 and 4. 10 and 4 is 14. What else multiplies to equal 40? 5 and 8. I think I heard that. 5 and 8. 5 plus 8 is 13, so those are our numbers. So we got y plus 5 times y plus 8. Excellent. Let's see, number 20. We have a negative for the addition. We have a positive for the multiplication. That's set 4, so both factors are negative, which works a lot like set 1. Bless you. So two numbers that multiply to equal 48, same two numbers that add to equal 16, just make them both negative. What do you think about that one? We can just start with two factors of 48. What do you think? $12 and 4. How about that? 12 and 4. What does 12 plus 4 equal? 16. All right, make them both negative, and that's it. So W minus 12 and W minus 4. Cool. A couple more here, 21 and 22. Both of these are negative this time, so that is set 3. So we need a positive and a negative for our factors, and the negative one has to be larger. So we need two numbers that multiply to equal 30. Let's start there. Five and 6. All right. Now, if we make the larger of these two negative, if we add those together, do we get negative 1? Yeah. So positive 5, negative 6. So n plus 5, n minus 6. Great. Last one from the mixed practice, and then we'll do some GCF examples as well. Okay, both positive. So we need both positive numbers, factors of 42 that add up to 13. What two numbers can you think of that multiply to equal 42? 7 and 6. 7 times 6 is 42. 7 plus 6, 13. Nice. These are both positive this time, so k plus 7 times k plus 6. All right. So that's how we work on those. Now the last 6 problems here, these ones are going to be like what we did at the end of the lesson yesterday, where we're going to factor out a GCF first, then we're going to factor the remaining trinomial. So on number 23, what would the GCF of those 3 terms be? What can we divide out? What's the largest thing to divide out of all 3 of those? 4, yeah. Those are all divisible by 4. So we'll factor out a 4. We're going to have to write pretty small because we need to leave some room for some more work. So if we factor out a 4, that leaves us with k squared plus 3k plus 2. And so the trinomial that we have is a plus and a plus, which is type 1 or from set 1. So both of our factors need to be positive. What's the only way to multiply to equal 2? There's only one way to do that. What is it? For the multiplication. 1 and 2. Yeah, so 1 and 2. 1 times 2 is 2. 1 plus 2 is 3. So that works. So we got 4 times k plus 1 times k plus 2. That's our answer for 23. Let's check out 24 then. What's the GCF of 24? What can we divide out of all 3 terms on 24? 2, yeah. We need to divide a 2 from the 2, the -8, and the -24. So 2, 2, 2. 2 times x squared minus 4x minus 12. So this time we have a minus and a minus. That was set 3, so we need a positive and a negative factor, and they have to add to equal -4. The greater of the 2 numbers is the -1. So again, just start with 2 numbers that multiply to equal 12. 6 and 2. All right, so 6 and 2. If the greater of those ends up being negative, does that add to equal -4? Yeah, that's it then. So 2 times x minus 6 times x plus 2. Cool. Problem number 25 is next. What can we divide out of all 3 of those on 25? 3, yeah. These are each divisible by 3. So we'll factor out a 3 from everything first. And that'll give us 3 times y squared minus 5y plus 4. So this time we have a negative in the middle and a positive at the end. That was from set 4. So that means that both factors are negative. So we just need 2 numbers that multiply to equal 4, and then make them both negative to add up to -5. What do you think about that one? What's the first thing you think of when you multiply to 4? I think it's probably 2 and 2, right? All right. So if it's 2 and 2, and they're both negative, that would add to equal -4, which actually doesn't work. So what's the only other way to multiply to equal 4? 1 and 4. If 1 and 4 are both negative and you add those together, we do get -5. So those are our factors, -1 and -4. So we get 3 and then times y minus 1 times y minus 4. Awesome. A few more here. 26. What are we going to do with that one? What can we factor out of all 3 of those? A 3, yes. And what else? And an a, yeah. So they all have at least one factor of a. Factor out the smallest exponent of a, which is 1. So 3a is our GCF this time. 3a. And we factor that out, 3a. That'll give us a squared plus 10a and then plus 21. So a squared plus 10a plus 21. We have a plus plus this time. That was from set 1. Both of our factors need to be positive. 2 numbers that multiply to 21 and add to 10. 3 and 7. Yep, and they're both positive. 3 times 7 is 21. 3 plus 7 is 10. So we're looking at 3a times a plus 3 times a plus 7. Cool. 2 more to go. What can we divide out of? Actually, you know what? Try number 27 on your own. Stop myself there. Try number 27 on your own. Take a couple minutes on that. Divide out the GCF first, then figure out your factors. After A was just fast, sorry. Okay. After capital. All right. Getting close to being done here. What is it, 25 today? Okay. Let's see real quick here. Yeah, 11:25. So we've got about 14 more minutes. And we'll have plenty of work time tomorrow. So if you don't get the assignment finished by tomorrow, we will have work time because we got a review tomorrow as well. So plenty of time to get caught up on things tomorrow. So let's have a look here. What did we divide out of everything on 27? 2. All right. So if we divide out a 2 from everything here, that'll leave us with 2 times b squared plus 5b plus 6. So we're looking at a plus plus. So both factors need to be positive. So what 2 numbers are we using? Was it 2 and 3? Yeah. 2 and 3. 2 plus 3 is 5. 2 times 3 is 6. So we're looking at 2 times b plus 2 times b plus 3. Nice. And our last one here. Oh my, look at that. Okay. What is our GCF on number 28? 5 for sure. The number is 5. Any variables? Y? Yeah, 5y. So 5y is our GCF. All right, now that will leave us, so 5y times, that'll be x squared. And remember, the trinomials we're factoring today, Catherine, you could go. The trinomials we're factoring today always start with just the variable squared. So if there is a number in front of our variable squared today, you will be able to factor that number out. And then minus looks like 3x. And what is that, 28? Is that right? 140 divided by 5, 28, I think. Yeah, so minus 28. Okay, both negative. 2 numbers that multiply to 28 and add to -3. So you got to, or not both negative, sorry, 1 positive, 1 negative. The greater one is the negative one. So give me 2 numbers that multiply to equal 28. 7 and 4. All right, now if the greater of those 2 is negative, does that add to equal -3? Yeah, all right, so that's it, -7 and 4. So we've got 5y times x minus 7 times x plus 4. Okay, that's it. I'm going to go get you your assignment. We've got about 10 minutes of work time, even though we have a shorter class period today. So nice work. We made through it. Made good time.